Hey gang, thanks for bearing with me this week. I know it's kind of weird. We're doing a virtual class, but when your bestie needs you, your bestie needs you. So, thanks for bearing with me while I'm in Virginia for a funeral. Today we're going to talk about chemical reactions and chemical equations, and we're just going to ditch Lab 11 and replace it with a video that I have that helps you learn how to balance chemical equations. And it's a really fun activity where we use actual real marshmallows. And I already have the marshmallows, so we will be doing it in little pieces in class throughout the next couple of lessons to make sure that you guys have an opportunity to do that hands-on activity. So let's get started with this. Let's have some review of physical and chemical changes. Remember that a change of state or form without a change in chemical composition is a physical change, and that if one or more substances are altered into one or more different substances, you know that you've had a chemical change. So how do we describe chemical changes? A chemical reaction involves the rearrangement of the molecular or ionic structure of a substance as opposed to a change in physical form or a nuclear reaction. A chemical reaction also is a process in which one or more substances, also called reactants, are converted to one or more substances, also known as products. A chemical reaction can also be described as a process that leads to the chemical transformation of one set of chemical substances into another. So, what are our signs of chemical reactions? How do we know that a new substance has been formed? So, this is review. We've talked about this before. So, one of our most obvious signs would be a change in color. This is obvious when you see fruit rotting or leaves changing color or fruit ripening on the vine. It's also obvious when you use pH indicators, like for checking your pool water. You can have the production of an odor. This is an obvious one, stinky shoes. We've talked about stinky people in the past as well, but this can also happen when, like I mentioned before, fruit rotting can change color, but fruit rotting can also produce an odor. And this would be the formation of a precipitate. This is when you have two solutions that mix together, and when that happens, a solid is formed. And when that happens in chemistry, we call it crashing out of solution, which is probably my favorite chemistry term. Such a fun one. You also can have evolution of a gas. This is really obvious with the old baking soda and water trick, right? That makes bubbles. So you know that a gas has been produced. Another way to tell that a chemical change has taken place is when you have a change in temperature. Some things will get warmer, some things will get hotter. Endothermic reactions are absorbing energy because bonds are being formed and they get colder. Exothermic reactions are releasing energy as bonds break and they feel warmer. You can also have the production of light. Glow sticks are a great example of this. And since we're having Halloween, you'll be, ooh, I have things popping up on here. I don't know why that's there. Sorry. Oh no, go away. Just go away for right now. Sorry, I don't even know if y'all saw that, but I could see stuff popping up on my screen. Anyway, I apologize. Production of light. Glow sticks are a great example. And you can also have production of sound. And in this case, with the fireworks, you have a chemical change that's taking place with the combustion. And then the sound is coming from the longitudinal waves being produced, passing through the air very quickly. And then there's a concussion that occurs. And then you can also have the absorption or release of electrical activity. Using a chemical battery that you put in a remote control, for example, is another good example of this. So let's talk about reactants for a minute. All right, so a reactant is a substance that takes part in and undergoes change during a chemical reaction. And in a chemical reaction, they are located to the left of the arrow in a written chemical reaction or equation. So you have reactants, yields, products. Reactants on the left of the arrow. Remember, the arrow you read as yields. Products are the substances that are formed as a result of a chemical reaction, and they're going to be located to the right of the arrow in a written chemical equation. Again, you have reactants, yields, products. So now let's have a look at chemical equations. Okay, so equations can show physical states and reaction conditions. So when you see things like this little S, L, or G in parentheses, and they're usually italicized when you see them in typeface, and they are for your state of matter, whether it is solid, liquid, or gas. You can also have this one. This is aqueous, which means it is dissolved in a water solution. And you've actually worked with aqueous chemicals this year, even if you haven't noticed it yet. And again, you read this as yields or produces. And this shows the reaction is reversible. Sometimes you'll see that. When you see this little symbol here, remember this is a delta and it means change. And this means heat. They'll actually write heat. This can mean a change in heat or a change in temperature. And sometimes you'll see the word catalyst written. A catalyst is something that lowers the activation energy of a chemical reaction so that it can occur more quickly or more easily. And in nature, like within the human body, for example, and other parts of nature as well, but we have specific biological catalysts that we call enzymes. So how do we balance chemical equations? Okay, so this is going to be a quick lesson, and remember that there will be further instructions in the video that's replacing lab this week. So chemical equations, remember, we have to conserve mass, rearrange atoms, and that they are always balanced. So subscripts and coefficients. Subscripts indicate the number of atoms of an element present in a molecule or formula unit. So all these little twos. So this would mean 2 sulfurs, 2 oxygens, 2 oxygens, 2 oxygens. But over here we have coefficients, and they show the relative amounts of each substance present. So 3 and 2. So there are 3 O2s. That means there are 6 oxygens here. But you have a pair of oxygen, a pair of oxygen, and another pair of oxygen. And then your SO2 over here, you have 2 of the SO2s. So you have an S, a sulfur, with 2 oxygens, another sulfur with 2 oxygens. So what does a parentheses have to do with anything? So polyatomic ions can be grouped together, and you place parentheses around them. Remember, polyatomic ions are contain more than one ion. So how to balance chemical equations. All right. We're going to work through this one step by step. I'm going to explain it to you, and then you're going to do it again when you go over to the lab video. The first thing you're going to do is draw your bracket. Do this methodically, and seriously, probably get a paper and pencil and copy these steps down as I work through them so that you're doing them along with me. That's probably going to be the easiest way to kind of keep up with what's going on. So you draw your little bracket. It looks kind of like a T with a little stick on the top. And then you place your reactants and products on opposite sides of that bar. Reactant, product. Do you agree? Yes, there they are. All right, and then what you're going to do is you write the total number of atoms of each element on each side of the bar, but you have to use the following order. And it's metals, non-metals, except for hydrogen and oxygen, and then hydrogen and oxygen. And you have to do it in that order. So if you come back to class next week and you have written down for me on a piece of paper a good mnemonic to memorize this order right here, I'll add a point to your lab. So these will be metal, non-metal, hydrogen, and oxygen. So you want something that's MnHO, kind of like, we did King Henry died unusually, blah, blah, blah. Same idea. See what you can come up with. So you're going to write them down. We have 2 iron, then we have 1 carbon, then we have 3 oxygen. So there's our metal. And then we did them just in order left to right. And then we had the non-metal, not really a situation. So then we got down to the oxygen. Same thing here, in the same order on both sides. All right. So now what we have to do is we're going to look at these relative amounts, these ratios. So first balance the metals, next balance the non-metals with hydrogen and oxygen last. Now remember, you can't change subscripts, but you can change coefficients. If you add a coefficient anywhere, be sure to change the number of all the elements it will alter. So here's how this works. How many iron do we have? We have 2. How many iron do we have? We have 1. They're not the same. So we need to turn him into 2. How do we do that? We can't add a subscript. We can add a coefficient. There it is. 2. 2 iron. All right. Good. 2 and 2. Check. Moving on. Carbon. We have 1 carbon. We have 1 carbon. Are we good? All right. We're good. Moving on. Oxygen. We have 3 oxygen. We have 2. Oh, that's not good. Now what do we do? Now this one may be a little trickier. How did we get from here to here? We just added 1, but how do we fix this situation? Easiest thing to do, it's kind of like when you're balancing fractions or working with fractions, multiplying them and whatnot. Look, you can just multiply these times each other. So if we do 2 times 3, we're going to get 6. All right, so we need 6 oxygen. How do we get 6 oxygen? We can't change this, but what can we do? We can add a coefficient. We put 3 here. We now have 6 oxygen because we have 3 pairs. All right. So then we have to go over here and go, well, this isn't 3 anymore. We're going to multiply it times 2 to get 6. So now how are we going to fix that? Well, we have 3. So what do we need to do? We can't change the subscript. We have to change the coefficient. We have to put a 2 here. Now we have 2 groups of 3. That's 6. All right, so we're good. 6 and 6. So we're done, right? No, we're not done because now we messed with stuff. So now we got to go back to the beginning and look at it again. So now we've balanced our first non-metal and we got to go check that all our metals are still balanced. So let's see. What do? We go back to the beginning and we say, man, we don't have 2 anymore, do we? How many do we have? We have 4. Oh, and now how many do we have on this side? We still have 2, but we don't want to keep 2. We want to have 4. How do we fix that? Well, that's an easy one. You just make it 4. Now you have 4. Do you agree? 4, 4. Check. So now we check out our carbons. We had 1 and we have 1. Well, we still have 1 on one side, but we don't have 1 over here anymore, do we? We have how many? We have 3. How do we make it 3 over here? We add the coefficient, and now we have 3. 3 and 3. Are we good? We're good. Check back on our iron. 6 and 6. Are we good? We're good. And you did it. That equation is balanced. Congrats. All right, now check your notes and then we'll practice some more. Let's see. Here are our notes. State the law of conservation of mass. In ordinary chemical changes, mass is neither created nor destroyed. Using the law of conservation of mass, explain why the following reaction is wrong. Hydrochloric acid plus sodium hydroxide yields sodium chloride. Well, the mass is not conserved because your hydrogen and oxygen just disappear. So that can't be right. Both sides, how can you tell when an equation is balanced? Both sides contain an equal number of atoms of each element. Consider the following balanced equation for the reaction between iron, metal, and water. Is the 3 in 3Fe a subscript or a coefficient? It's a coefficient because we talked about how when you're doing all this balancing, you don't change the subscripts, right? And clearly it's in front, so it's a coefficient. What is a subscript in the water molecule? And it's a 2. There it is. Coefficients change how does changing a coefficient differ from changing a subscript? Coefficients change the amount and subscripts change the structural identity of the substance. Why is iron balanced as 3Fe instead of F3? Subscripts can't be changed as they affect the structural identity of the substance. Sorry, I can't talk. So scan this on your phone. This is a website that will let you practice balancing, and it has varying levels of difficulty. It's a lot of fun. Take some time and spend some time practicing it because you'll be doing a fair amount of balancing in class. So it's helpful to know how to do it well. So after you've done that, go on over, do your lab. Your lab is, we're just going to replace lab 11, like I said, with this video. And if you do have colored marshmallows at home you can use, go ahead. And if not, you can use M&Ms or Skittles or anything else that you might want to work with. Or you can skip the tactile part and move straight to the numbers. See you next week.